All right, we are working on the homework following the Bones and Stones lab where we investigated different ratios to figure out how to make the most product. So for the first one it says predict the products between CaCl2 and NaC18H33O2. Oh my goodness, it looks really crazy, but all this really is, this whole thing right here is just a polyatomic ion that must have a -1 charge because sodium's got a +1 charge. So let's find out what we make here. Now Na is going to be with Cl, and now Ca is going to be with C18H33O2, and this has a -1. Calcium's got a +2, so this will have a little 2 outside. Okay, now we're not balanced. We need a 2 here. And then let's figure out which one the precipitate is. Well, NaCl, if you check your solubility table, is AQ. This one is not on there, but this is a huge anion. So a lot of times when you've got something big like that, that's going to be the precipitate. So oh, this wasn't quite balanced up here. I just saw 2 Na, 2 Cl. We're going to need a 2 Na here as well, since there was 2 there. Okay, so let's look at the numbers out front. 1, 2, and then 2, 1. What ratio of drops of equal molarity would give you the largest volume of precipitate? Well, it would be a 1:2 ratio of the calcium chloride to the sodium oleate. You just look at the numbers out front. How about number 2, different reaction? Suppose you react FeNO3 with sodium sulfide. Well, check this out. What charge must this iron have if it's with 3 -1 charged nitrates? It must have a +3 charge. Sodium always has a +1, sulfide has a -2. So double displace, and you're going to have Na now with NO3. Na's got a +1, NO3 has a -1, and Fe is now going to be with sulfide. Crisscross those charges, you've got Fe2S3. Check your solubility table, you'll find out that Fe2S3 would be the thing that forms the precipitate. Now we're not balanced here. We've got Na2, NO3, 3. Let's start here. Fe2, we're going to need a 2 out front of the Fe. S3, we're going to need a 3 out front of the S. Now that makes 3 times 2, that's 6 Nas and 6 nitrates, so we're good. What is the ratio of drops that would give you the largest amount of product? Check the numbers out front. It would be a 2:3 ratio. Okay, last one. Suppose you reacted AgNO3 with CaCl2. Double displace, and you're going to have AgCl. Ag must have a +1 charge if it's canceling out nitrates, -1 charge. And you're going to have CaNO3. Calcium's a +2, nitrate's a -1, so this will be CaNO3 2. Now we're not balanced. NO3 2, we need a 2 there, we need a 2 here. The precipitate that forms, if you check your solubility table, is the AgCl. Nitrates are always aqueous. So this is the solid here. So check out the ratio, a 2:1 ratio. So let's see if any of these have a 2:1 ratio. 100 to 200, that's 1 to 2. 200 to 100, that's 2 to 1. So I can tell right away B is going to be my answer. But let's just look at the other ratios. There's a 3 to 1, and here is a 1 to 3. So this set of reactants would give you the most bang for your buck. All right.